All right, guys. So before we get started on the note sheet, on the notes today, are there any questions over any of these problems or any of those that you all want to look at? On my desk. Did you want to look at one of them? Okay. Yeah. Yeah, you can put them on my desk on my computer. I think the one you were asking about or seeing more.
I put that on the last one.
Yeah, no,
Oh, no, I accidentally put.
an extra piece there. You're good.
It meant to go on the other one.
And that's all they are. The X, and then the other one you added in that X is an element of the real numbers. But you don't need that because brace X bar is saying it's a part of the real number system. Yeah. But again, if you have questions on it, yeah. Yeah, for some reason I didn't see it till then, but yeah. Yep. You're good because again, I try to email back pretty quickly because it's preferably you get your answer now, not later. All right, guys, we're going to go on and get started. If there are no questions on the assignment, we're going to go on and look at 1.2. Right there. Yep. You can keep the note sheet. I just need the homework. So if you do feel comfortable about the homework and needing to turn it in, you turn it in on my desk. You can give it to me. Either one works. But we will go over homework questions. Now, I will say if you turn it in and we go over one of the homework problems and you want to check it, make sure it's fine, you can grab it out of that pile, fix it. There's nothing wrong with that. Now, what we're looking at today is describing transformations. So there are basic parent functions. These are 4 of them. There are many more than this. But a parent function is the most basic version of that function type. So constant functions, we really won't talk about constant functions much because there's not a whole lot going on. F of x equals 1, y equals 1 is the parent function of all constant functions, all of these flat lines. Because we can take any flat line, like this here, like the first one pictured, and move it up or down and get every other function of the constant type. Now, for the most part, we don't talk about it a whole lot because literally it's just f of x is equal to 1 plus k, where k is the amount we move it up, or we move it up to, it's now f of x equals 3. There's not a whole lot going on. We're mainly going to look at linear, absolute value, and quadratic. So linear is the equation of a line. Every other equation of a line is going to look similar to this parent function, y equals x, f of x equals x. Same thing's true for absolute value. Absolute value bars is our v, where the center, the lowest point, is at the origin. Every other absolute value function is going to look similar to this. It might not be there, it might be skinnier, it might be wider. We can apply transformations to it, but they're all going to look similar to this one here. The same thing's true for quadratic, our U-shaped graph. This is the parent function, the most basic version of it. We can tell it's a quadratic for 2 main reasons. One, the U in the U-shaped graph, or the x squared. Absolute value functions have to have, well, absolute value bars. If it has absolute value bars, it's an absolute value function. These are the most basic versions of these here. Questions on this so far? Now, we can apply different transformations to them. Now, the first type of transformations we're going to talk about are translations. But before we get to that, we're going to look at the general forms. Linear function. Now we are specifically going to go over each type and what each of these does, and the specific transformation that is connected to A, H, and K. Now there is another variable that is put into all three of these, and it's a B. The B is going to go in front of the X after the parentheses. So between that X and parentheses, there would be a B value. And it's specifically with some other properties, but we're not going to be looking at it today or tomorrow. So I'm not going to put it in there yet. Now, A, H, and K, and eventually we'll get B put in there too. Each one of these here, when we have numbers or values in each of these spots, is going to correspond to a type of transformation.
Is that a K or an R?
K. Mm-hmm.
Oh.
Yeah, so it's plus K outside for each one of these here. Yep. Yep, all Ks. So that's lowercase k. For the most part, I will write all my Ks in lowercase cursive. I will write Ys cursive and then print depending on the moment. It will switch between the two. But most of these here, linear, A, parentheses, X minus H, close parentheses, plus K. Quadratic are A, parentheses, X minus H, close parentheses, squared, plus K. Absolute values are A, absolute value, bar, X minus H, absolute value, bar, plus K. These are the general form, and A, H, and K are all going to correspond to different transformations. Now, the first type of transformation that we have here, it's a little blurry. A transformation changes the size, position, shape, or orientation of a graph. Specifically, we're going to look at translations first. A translation shifts a graph horizontally and or vertically, but does not change its size, shape, or orientation. All that's saying we're going to move it up, down, left, right. That's all we're doing is we're just moving it up, down, left, or right. Now, there's two main ones that we have. Vertical translation. A vertical translation is going to move it up or down for that value of K. K is our vertical translation. K is our up or down. The number that we have in place of K in all three of these here tells us how far we're going to move it up or down. Vertical translation is our K, which moves it up or down. Now our other translation that we have is horizontal. That is our left or right, which is H. Now this here, left and right, is a little tricky. It's going to be the opposite of what we think. It's going to be the opposite of what we think. And it's our H. If there's a value in that H spot, X minus H, it's moving it left or right. And especially when we talk about linear equations and we're looking at the equation, we're mainly going to reference it as up and down. We're not going to talk so much about left and right. We don't normally leave parentheses in linear equations. So H tells us left or right. K tells us up or down. Questions on this here? Let's actually see how this looks. So the first one here, graph. So we have the graph g of x equals x minus 4. and its parent function, then describe the transformation. I'm not going to have you graph. And it's not because I don't find graphing important and necessary. It's just that there's too many things and too many pieces of technology that we have that will graph for us. So I feel especially the ability to graph is nice. It's essential, and not essential, but it is helpful. But there's too many things that will graph and do the graphing for us that being able to do it is becoming not as important. Because here, if we look at this function here, x minus 4, what is it, the parent function? The parent function would be linear. It's equation of line, yes? So we would say that this is linear. And if I looked at the parent function, it'd be this line here. F of x equals x. We will get the graphing calculators out. It graphed it for us. But being able to actually understand what the graph is telling us and being able to read a graph is more important than being able to just draw the graph, because this just did it. Now our new one, our new function, x minus 4, yes? So if we look at it in comparison to our general form, the question is that minus 4, that 4, is it taking the place of a, h, or k? It'd be tempting to say h, yes, but we would need parentheses. Are there parentheses at all? If there's not written, they're not there. So that 4 is actually connected to not h, but k, yes? K is telling us it's moving what direction? Up or down, yes? How far are we moving up or down? Yeah, 4, yes? What do we think? Up 4 or down 4? Down 4, because it is negative, yes. So according to that, in that picture we have over there, we're going to move every point on that graph, how far? Down 4, yes? So that means that our new graph should look something like this here, yes? Because again, that's what I'm saying. We can graph it. I see that, okay, that function, this is the parent function, it should be down 4. If we can see that it helps us with solving more than anything else. Because then also I can come in here to the graphing calculator, y equals, let us graph, x minus 4, graph. It indeed moved everything down 4. Being able to see and understand what's happening is more important than us being able to actually just graph the thing. Questions on this here? Let's look at the next one. G of x equals the absolute value of x plus 1. What's its parent function? Absolute value, yeah. It's kind of easy for that one because we got to say absolute value to actually say the function itself. All right. Now the absolute value function and you probably remember from Algebra 1 and geometry that we told you that the 30xs calculators cannot do absolute value functions. And that's true. The graphing calculators, it takes a bit, but we can go math over 1 to ABS. It'll graph absolute values. It will do absolute values. That is the absolute value function. That is the parent function of this here. Now we need to figure out where it's moving. For this one here, do we have a value for k? No, we don't have anything being added outside, but we do have something in place of h. h is moving to the function to the left or to the, now how far are we moving to the left or to the right? 1. Which direction are we moving? To the left or to the right? Right. Right 1. So we should see that this function, everything is going to move to the right 1, yes? Let's pull up the graphing calculator, y equals. And again, it does take a few keys to get over to absolute value. X plus 1, yes? Graph, and as we can see here, it moved every point 1 unit to the left. Because it didn't actually move it to the right, it moved it all of these points 1 unit to the left, yes? Okay, so not to left, right? Okay, now let's look back at the general form. Now in the general form, our x and x do match up, yes? In the general form, we have x minus h, yes? In the current form, we have it as what? X, well, plus. Well, the only way that we can change this here from a plus, from a minus to a plus, is if that one's actually not positive, but negative. Because a negative and a negative will make a, so for us to actually line it up to the general form, the value of h is not positive 1, it's actually negative 1. As I said a minute ago, left and right is going to be the opposite of what we think. Because if it's x plus 1, it does seem like it should be going to the right. It's actually going to the left. Because our value of h is not positive 1, it is negative 1. Since the general form is x minus h, the only way to get it to plus is if that value of h is negative. So our movement left or right is negative 1. The negative tells us to the left. The easier way to think about it, when we're inside those absolute values or parentheses, it's going to be the opposite of what we think. Left and right's the opposite of what we think. Up and down, exactly what it looks like. Plus 3 is up 3. Minus 4, down 4. Up and down is exactly what we think. Inside those parentheses are absolute values. It's going to be the opposite of what we think. And that is true, especially when we start talking about horizontal stretch and shrink. That's that b value. I mentioned that we are going to put in later. Horizontal stretch and shrink is the opposite of what we think. Questions on left and right? Let's look at the next transformation. Is a reflection. A reflection reflects the graph across a line of reflection. Over a line called line of reflection. A reflected point is the same distance from the reflected reflection as the original point, but on the opposite side of the line. There's two main reflections that we have. One is going to be across the x-axis. We say that it is reflected across the x-axis if A is negative. If A is negative. If the number where A is, in all three of these here, is negative, it's a reflection across the x-axis. We're not talking about specifically the number that A is, but if it is negative. If the number in a spot is negative, it's a reflection across the x-axis. If it's positive, there is no reflection. Okay? Because A, the number that's going in a spot, is one of the few transformations that's going to have two things. Most likely we're going to talk about it at the start of class tomorrow, but it will also have a vertical stretch or shrink. If there's a number there other than 1, we're talking stretch or shrink. If it's negative, it's a reflection. The negative with A tells us if there's a reflection. The number, its value, other than 1, gives us stretch or shrink. We kind of see that there. A is going to have two things. B, inside those parentheses are absolute values. If that is negative, it's going to be a reflection across the y-axis. And here, for now, if that negative is attached to that x inside the parentheses or absolute values, it's going to be a reflection across the y-axis. Now, for the most part, x squared, absolute value of x, this tells us pretty much nothing. We can have a reflection across the x-axis or the y-axis for these here, and it doesn't do a whole lot. I'm going to turn this off. So here's our parent function for the absolute value graph. If we reflect it across the y-axis is going straight up and down, straight through the center of this, yes? So it means every point to the left of the graph is going to go that same distance to the right of it from the y-axis. Well, it's already over there, isn't it? Which means all the points to the left of it are going to be on the right line, and all the points to the right of it are going to go to the left. And it's one thing for me to say it, but this is going to go real quick, actually. Yeah, graph. You get the same function back. That's why we don't talk about reflection across the y-axis here, because especially for quadratics and absolute value, just the basic absolute value function, you get the function back. The absolute value of x is the same as the absolute value of negative x. But once we get it away from the y-axis, where the y-axis isn't cutting the function in half, we do get some different functions. So let's look at this here. Graph, so we have p of x equals negative x squared. So what would its parent function be? It would be a what? Quadratic. I've been doing it for the lesson so far. I'm going to give a rough. So we have this quadratic function. The bottom of the U shape really will hit the origin. It's going to go through 0, 0. So this is our quadratic function. Our f of x equals x squared. General form. We don't have parentheses, so there is no h. There is no movement left or right. Do we have anything being added to it? No, so there is no value for k. There is no up or down movement. The only thing we have different from the parent is that a, where a is, it is now a negative. Since the a is negative, it is a reflection across the x-axis. I realize I didn't write the rest of this. There we go. Since a is negative, a has that negative, we have a reflection across the x-axis. That is the transformation. Because the value in that a spot is negative, not so much the number, the value's negative, it's a reflection across the x-axis. Which means every point above the x-axis is now going to be that equal distance below. So the new function will be this here. And really they should both be hitting that 0, 0, the origin, but missed it just by a little bit. Questions about these so far? We feel good with these so far. All right. k of x equals negative x. The parent function would be what? Linear, equation of a line. Okay. A times x minus h plus k. There's nothing being added to the end of it, so there is no k. There are no parentheses, so there is no h. The only thing we have different from our parent function is that negative in front of the x, which is our a value. Since the a value is negative, it's going to be a reflection across the x axis. That's it. So our x-axis is here, which means all of these points that are above it are going to now be below it. All these points that are below it are now going to be that same distance above it, because we're just flipping it across that x-axis. So instead of increasing from left to right, it's now going to be decreasing from left to right. Yep. Questions on this here? I think it'll be good to look at a few that aren't just specifically reflection, just immediately what we have. So if we look at the first one, g of x equals x plus 3. So what parent function would this belong to? Linear, quadratic, absolute value. Linear. Because it's just equation of a line, linear. Now you do not have to write this above it each and every single time, a times x minus h plus k. I'm putting it there, and especially for these first few days when we're starting to get used to this, to being able to see what is going where, what is taking each of these letter spots, what are they connected to. Because if we look at this here, do we have anything in a spot besides 1? No. Do we have parentheses? Well, we don't have parentheses written for g of x on that side, so can we have an h value? No, because h has to be inside those parentheses. Do we have a k value? Yeah, the k value is 3. Now, k tells us that it's moving the function in which two directions? Up or down, yes? Since it's plus 3, it's telling us it's moving 3 units up, because up and down is exactly what it looks like. Plus 3 is going to be up 3. If it had been minus 3, it would be down 3. Up and down is exactly what it looks like. Let's look at the next one. H of x equals x minus 2 squared. It would indeed be quadratic. That square, that exponent of 2, tells us this is a quadratic. That's do we have a value for a other than 1? No, there's not a number in front of the parentheses. Do we have a value for k? Do we have a value for h? Its value is 2. So now we need to determine, are we going to the left or to the right? Opposite of what we think. It would be to the right. And especially if we look at the general form here, the x and x do match up. The minus and minus do match up, which means h has to be 2. Positive 2. 2 units to the right. Opposite of what we think. Opposite of what we think, it's going to the right. N of x equals negative absolute value of x. Well, this is Absolute value. So when we look at the general form, do we have a value for k other than 0? Do we have a value for h other than 0? Do we have a value for a? Yeah, a is 1, but it is negative. Because there's a negative in that a spot, we know it's a reflection across the x axis. Even though a is 1, because it's negative, it's a reflection across the x-axis. Questions on these transformations so far? Are you ready for our next one? The last main one we're looking at here is vertical stretch and shrink. Vertical stretch and shrink. Another way to transform the graph of a function is to multiply all the y-coordinates by the same positive factor other than 1. When the factor is greater than 1, it's a vertical stretch. When that factor is between 0 and 1, it's a vertical shrink. So what we can say, it is a vertical stretch when a is greater than 1. And it's a vertical shrink if a is between 0 and 1. If 0 is less than a is less than 1. If a is between 0 and 1, it's a vertical shrink. If a is greater than 1, it is a vertical stretch. Now with stretch and shrink, we're specifically looking at the number for a, not its sign. Because if that a is negative, that negative is attached to the reflection. The value, the number of a, is attached to stretch or shrink. Now the pure definition version of this, they would say if the absolute value of a is greater than 1, it's a stretch. If 0 is less than the absolute value of a is less than 1, it's a shrink. Now the reason they add those absolute value bars is just in case the value of a is negative. But I think at this point we have the wherewithal, the understanding to know if that number is negative, the negative is with the reflection, the number itself is with stretch or shrink. Would we agree with that? Because when we look at this a, I'm looking at the number. If it's greater than 1, it's a stretch. If it's between 0 and 1, it's a shrink. So if we had negative 2 absolute value of x, the negative is telling me there's a reflection across the x-axis. The 2 is talking about the vertical stretch or shrink. A is the only one, A and B are the only ones that can have more than one transformation with that specific number. Negative tells me it's a reflection. The number tells me if it's a stretch or shrink. Questions on this here? We'll pick this up tomorrow.